Hey all, welcome to the next video on symbolic notation. Still talking about conditional statements. We're getting into three things called converse, inverse, contrapositives. But first we're just doing a little bit more, I guess, kind of a review of the symbolic stuff. It says, using the following information, write the symbolic notation into written form. So up here we had sentences and we wrote it into this. Now we're going to do the opposite. We're going to be writing down a sentence. P means all sides are equal, and Q is the polygon is equilateral. So you would just start with the whole if, because remember this arrow means if then. So that just tells you we're going to have if something, comma, then something. That's going to be our answer. If something, then something. And it says that the first thing is P. And it says P is this thing. So if all sides are equal, then Q. The polygon is equilateral. And I'll take a quick read through it to make sure grammatically it's correct. If all sides are equal, then the polygon is equilateral. Grammatically it's correct. I feel like in a sentence I would say if a polygon has all sides equal, then the polygon is equilateral. But you know, that's a different subject. That this is grammatically correct and it has what we want. So that would just be your answer. You write whatever P is with the word if in front. You then write then, and then you write the second thing, which was Q. Boom, done. You have to be able to do that to do the converse, inverse, and contrapositive. So first of all, the converse. The converse and inverse are actually words I sometimes use in life. I can't say that about everything I teach, but converse and inverse I use in life, mostly converse. That one comes up a bunch in debates. Inverse a little bit. Contrapositive is the most useful, but people don't say it out loud. So converse is formed by switching the hypothesis and conclusion. So instead of the hypothesis and then conclusion, you would switch those two statements. And then this would be the new hypothesis and this would be the new conclusion. They just completely switch. So instead of P, Q, it would be Q and then P. You switch them. Versus inverse. Inverse is formed by negating the hypothesis and the conclusion, which you probably don't know what negating means. Which is why there's a little note over here, negation. Negation is opposite in terms of like yes, no, or is not. Emphasis on the word not. I'll even put another one here. Not is very, very common in these things. You'll be seeing you insert the word not, or if the word not is there already, you just take it out, and that's the inverse. So symbolic notation, the symbol for that is a tilde. That is called a tilde. So symbolic notation would be instead of PQ, it would not be not P and not Q. And you would just pronounce that not. You don't have to say inverse, you just say not. Not P implies not Q, or not P then not Q. If not P, then not Q. And finally, contrapositive. It's the longest word and it does the most. It does both of these put together. Not only do you switch the P and the Q, but you also negate them. So it is formed by switching and negating. Boop, boop, ba-doop. So not Q implies not P. You switch the P and the Q and you put the tildes in front. That's the contrapositive. Like I said, contrapositive is the most useful, but people don't say that word out loud for whatever reason. People use converse a bunch when they say sentences. It's like, well, conversely, this other thing is true. Or it's like, you just said that, but really that's just the converse, and the converse isn't true. And you know, high society and all that jazz. For examples, write the converse, inverse, and contrapositive of the following. And here's an example. If it is Saturday, then there is no school. So luckily it's giving you a pretty clear, this is P and this is Q kind of going on here. So for the converse, it says to simply switch these two. So instead of saying it is Saturday, there is no school, for the converse you would say there's no school, it is Saturday. So I'm just going to do that. It is still the whole if thing, and then over here there's going to be the then. But if there is no school, then it is Saturday. And that's it. You switch the two. Saturday is now on the right side, no school is now on the left. Symbolic notation, as we said up here, it's just Q and then P. Q, arrow, P. For inverse, this is the one where you put knots. So instead of it is Saturday, instead of it is Saturday, you would say if it is not Saturday. You just put the word not. So instead of is not. And then if there is already a no, then you take it away. Just like in this one, the next part, it says then, it says there is no school. Well, what's the opposite of there is no school? Forget about math, forget everything I've said. What is the opposite of saying there's no school? What is the opposite of saying there is no school? And that is, there is school. It just gets rid of the word not. Now, that's not a true statement, but we don't care about that. So, symbolic notation, not P implies not Q. Boop. And finally, contrapositive, we do both. It's going to be the not Q and then the not P. So I'll just do that part first. Not Q implies not P. Forgive me for using the word imply. I did this in symbolic logic in college, and that's what the vocab they use there. Because logic and math are technically a little different. But this is not Q, arrow not key. So if not Q, then not P. So not Q would be this one right here again. So not this one. There is no school. The opposite of that is there is school. So if there is school, then the opposite of P. It is Saturday. So it is not Saturday. So you always do the opposite. You put the not or you take the not out. Pause it, see if you can figure it out, and then I'll put it down for number 2. If the temperature is 25, etc. Converse, you switch the two. You still start with if, but you start with this one. If it is below freezing, then the temperature is 25 degrees Fahrenheit. That is the converse. You switch the two. Don't know if you noticed, but that's not a true statement. It's false. It can be below freezing, but not 25 degrees. But we don't care if it's true or false yet. So converse, Q implies P. Inverse, once again, I would pause it, see if you can do it. Not P, not Q. The temperature is 25. Oh yeah, well, what if it wasn't? If the temperature is not 25 degrees, then it is below. Psh, then it is not below freezing. You just put the word not. And then contrapositive is both, not Q, not P. So if it is not below freezing, then it is not 25. If it is not below freezing, then it is not 25 degrees Fahrenheit. There you go. Some symbolic notation. This goes pretty fast. In terms of what you need to know for symbols, the only two ones we haven't done so far are this little caret and upside down caret. It looks kind of like a V. This right here means and this right here means or. Oh gosh, I don't remember what grade you see it. It might be actually in Algebra 2 where you see this symbol and that symbol. It might even be later, I'm not sure. These means intersection and union. That's going to be a year or two probably before you see, but it's still like the same shape. There's something like that, which means and or and the or versus or kind of stuff. But all we're doing in logic is these two symbols. This means and this means or. Same thing, this means negate or not. Then P and Q are just symbols. So it says to write out a sentence. Use the following information, write the symbolic notation into written form. So this is P, which is this thing. So P, I'll just write it out. Notice that there is no arrow. I should say that. There is no arrow. Since there is no arrow, there is no if-then, right? The arrow means if-then. There are no arrows on this, so you will not be writing if, you will not be writing then. It is simply P. What is P? P is Daniel is angry. He is angry that these videos are so long. He wants to get out of here. Daniel is angry. And then this symbol right here is the word and. And then Q says Daniel is not having fun. Remember, this is saying it wants to do the opposite. So what is the opposite of not having fun? And that is having fun. And Daniel is having fun. He is fun. He is angry and he is having fun. That is very interesting. I wonder what he is doing. Daniel's angry and he is having fun because that word not got negated. In the next one, it says Q, which is Daniel is not having fun. And then this little symbol right here means or. And then not P. So not P means the opposite. So what's the opposite of being angry? Daniel is angry. The opposite. Daniel is not angry. And that is it. Like I said, it's useful to be able to do things in if-then statements or notations like this, because mathematically, after you have things written like this, it's simply switching. And it's not, it's like, it's going to take you time to get used to it. It's a lot of vocab. It's which thing do you do which for? When do you switch? When do you negate? I don't know. It's vocab you have to know. It's things you have to get used to. But it's also one of those things that, like, when all is said and done, it's not critical thinking. You have a symbol that means not, so you literally write the word not. That's not an understanding, that's not an application thing, that's just vocabulary and using it. And that's what mathematicians like when it kind of comes down to it. They like formulas you can just plug in and be done. They like a form where you can just switch two things and be done. They try to simplify it as much as possible so that when they get to more complicated stuff, they don't have to worry about that. So that's where we're leaving off with this. And yeah, I think that's it. So have a great one.